Good morning, everybody. Welcome to a wonderful Monday morning at Chem 1211. Boy, was I surprised this morning. Just a little while ago, I went to open up my interface when I log into Zoom as the moderator or the owner of this meeting, and it was gone. Ah, I don't know what happened. I didn't delete it, but it was gone. So I had to set up another one. Hopefully you got my email. It's also an announcement on Blackboard. The new login information is there. I'll change it on the syllabus sometime later today or tonight. But we've got a new login. Check your email and you'll be able to see me on Zoom. I'll still be posting everything on YouTube. Luckily, I think that hasn't disappeared on me. Oh, what a way to start your week. I hope you all had a nice weekend. I did a lot of stuff around the house, including washing my car yesterday. It's in my garage now. It's going nowhere today. And later today or tomorrow, I will wax it. And I'll talk more about that another day. But I've got an older car and it looks almost brand new because as a chemist, I know organic chemist, what's the best wax out there, and you should do it at least twice a year, which I always do. All right, let's get to important information. Again, new login for Zoom. Check your email. As you notice, there's the announcement. Well, I only got one person. John, do you see urgent? Everybody's getting in. My two G's. Both Giannas are here. All right. Again, new Zoom login. I don't know what happened, but Zoom wiped out my old login. All right. More important information. Everybody, can you see test one important information on your screen? Thank you. All right. Next week, a week from today, I won't be, but you'll be taking test number one during the week of 10/17/22. At that time, you'll have from a week from today, next Monday through next Thursday, not this week, the following week. I like my hand motions for following week or like that. But anyways, to take test number one at the Glen Ellen Testing Center. And you'll need a picture ID. I'd highly recommend bring your own calculator because you'll know how to use it. If you don't know how to do scientific notation on a calculator, come to my office hours this Tuesday or Wednesday, and I'll be more than happy to help you with that. If you can't make it to my office hours and you need urgent help, email me and I'll see if I can fit you in when you're available. I can do that because we're on Zoom and you don't have to meet me at COD. All right, back to test number one. Test number one will be chapters 5 through 10, which will cover chemical bonding, including ionic and covalent bonds. It will cover mole and all the mole related topics, including balanced chemical equation. I think there's 4, but don't quote me, either 3 or 4 balanced chemical equations. So know how to do that. Test number one will have 21 problems, 9 pages. There are no multiple choice, but some of the questions have multiple part, like A, B, and C. And it will have, for chemical bonds and related topics like Lewis structure and things like that, 49 points. For mole and mole related topics, including balancing chemical equations, we'll have 56 points. It'll be a total of 105. So there's five extra credit points or bonus points. Now, the way I do bonus points or extra credit points is I don't have a big, real tough problem at the end of the test that almost nobody can do. No, I just have the whole test add up to 105. You pick which 5 points are your bonus. Not really. I just have it add up to 105. Now, under your name, it will say, please use proper significant figures for all calculated answers, and something new, which we've talked about, please use 3 significant figures for all atomic masses. If you don't do any of those, either of those in a problem, I take off 1 point. If you do enough of them, you can lose a lot of points. So please use proper significant figures for all calculated answers, and please use 3 significant figures for all atomic mass. Now, how do you get the test back? Well, I'll be posting the test Saturday. The test center is closed on Friday. And don't forget, this not this week, but next week. I will pick up the tests and grade them. And I guarantee by Sunday, 4 p.m. of 10/23/22, your test scores will be in Blackboard. And probably even hopefully a little earlier than 4 p.m. At that time, I will post an announcement and send you an email that your test scores are in Blackboard. And also by 4 p.m. Sunday or earlier, I will email you each individual student, the points you receive for each problem or each part of the problem on the test, so you can know what you did good or not. On Monday, I will go over test number 1 answers in our Zoom meeting, but I'll cut it out of the video. I don't want it floating around the internet. And if you cannot make my Monday Zoom meeting, come to my office hours. If you can't do office hours, let me know. We'll set up a special meeting so you can see the test answers. Thinking about sometime after that Monday, coming to COD, maybe on a Saturday morning. And if you want to pick up your actual printed test for test number 1, I'll be there. We'll have to work something out. If any of you have an idea, let me know, because I can't mail them back to you. I had asked if the division would let the receptionist at HSC have tests and give them back to you, and they said no. So I tried. Now, this week, today, I'm going to go through Chapter 6 practice problems. Tomorrow, I'll go through Chapter 7 and 8 practice problems. And on Wednesday of this week, I'll do my review for test number 1. And I believe I changed it, and also important information is now available called test number 1 in Blackboard in the lecture section. All right, another issue I want to talk about is a lab order and other things. I looked at the lab schedule and realized I should have switched, which I did, but not in the syllabus yet. And I probably won't, but I just switched the balanced chemical equation lab with the periodic table lab. So this week, and I've already got it set up, and I'll go through it tomorrow, you have a balanced chemical equation lab. Now, I'd highly recommend that you get it back to me by end of the week so you can see how well you did. And next Monday, I'll go through the answers for that. So if you haven't taken test number 1, you can see what you've done. Also, as of this Saturday, I posted all the graded lab scores in Blackboard. If you do not see a score for a lab, then 1, you never handed it in, or it was handed in after I graded the labs. When I do a lab, I do the whole class. And if you hand it in late, I haven't gone back and do that. So to tell me you've handed in a lab late and it wasn't graded, send me an email which lab to grade. Also, some of you, and I just haven't had time, I've been really busy with a lot of personal stuff lately. I apologize, but that's life. I could not, if you didn't have a score and you handed it in and it wasn't late, that meant I couldn't open the file you uploaded, or one person, no, I think two people uploaded a blank file. So you should upload that lab again and check before you upload it that it's got your answers in the file, and send me an email to grade that lab or labs. Well, I think I'm up to date. And once again, let me remind you, Zoom wiped out my interface for the lab, our class meetings. So I set up a new one. I've sent you an email and it's an announcement here in Blackboard. All right, any questions before I move on? All right, let me do one thing. Hang in there a minute. I'm looking for something. And I found something. All right, let's go through. All right, sorry about that. All right, everybody see chapter 6, practice problems on your screen? Thank you. All right, let's go through. These are important things you should know for test number 1. First of all, what is a mole? It's a chemist counting unit. What is Avogadro's number? 6.02 times 10 to the 23rd. Those are things you should know. Now, let's look at some problems. How many atoms are in 6.74 moles of sodium? So what are you being asked to find? How many atoms sodium? And I use the chemical symbol Na, sodium. What are you given? 6.574 moles of sodium. Here's the only number you can start with. Your answer is atoms. Sorry, I wrote this out, but hopefully everybody can understand this. Atoms of sodium. And now it's time to use your good buddy, your good friend, unit analysis. And atoms of sodium goes on top of a ratio to convert moles of sodium to atoms, and moles of sodium or mole goes underneath. Where do you get that information? You look at test number 1, important information. These will be the last 2 pages of your test when you take it next week. And you'll see 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. So now we know 1 mole of an element equals 6.02 times 10 to the 23rd atoms of that element. Notice moles divided by moles cancel out, because anything divided by itself equals the number 1. We do the math, and notice this is 4 significant figures. 1 is an exact number, plays no role in your calculation of significant figures of your answer. And this 6.02 is 3 significant. When you're multiplying and dividing, the number that has the fewest significant figures is what your number should be rounded off to. And notice I do have 3 significant figures. On test number 1, show your work. If you get a wrong answer because you put in, instead of 6.574, you hit your calculator 6.754, you transposed the 7 and 5, and I've even done that. If you do that, now you can see that, or you had it set up and you get the wrong answer because you pushed the wrong buttons on your calculator, oh, you know what you're doing. If this were 5 points, I'd take off 1 point for a math error. You'd still get 4 points. So it pays to show your work. All right, let's move on. Number 7. How many molecules are in 23.45 moles of water? We're trying to find molecules of water. We're given moles of water. This is the only number we have to start with. There's some ratio. What would that be? Well, first of all, what units do you want your answer in? Molecules of water. So use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Where do you get these numbers? Important information. Test number 1 that you'll be given. 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And therefore, 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. In this case, it's water. Notice I have moles of water divided by moles of water, cancels out. I'm left with molecules of water, right answer. Notice 4 significant figures, 6.02 is still 3, 1 is still an exact number. When you multiply and divide, the answer should have the same number of significant figures as the number you're multiplying and dividing that has the lowest significant figures, which is this case 3, and I rounded it off to 3. Now, let's look at number 11. Well, let's, instead of 11, let's do 12. Now, notice I have a note here, which will be on your test. Please use 3 significant figures for all atomic weights. I'm sorry, this was written when I did this. These are a little old. So let's look at, first of all, what's the molecular weight of water? Well, the molecular weight is the sum of all atomic weights. And now I have to open up something. Give me a minute, maybe not a minute. All right, so we need the atomic weight of water, H2O, and water is the sum of all atomic masses, and hydrogen, well, to round that off to 3 significant figures, keep the 1, keep the 0, keep the 0, use to run, the 8 to round off, that's 5 or higher, drop that, the 0 in front of it becomes a 1, so hydrogen to 3 significant figures is 1.01. Now, if we look at oxygen over here, 15.999, keep the 1, keep the 5, keep the 9. First one. The second 9 after the decimal used to round off, that's obviously 5 or higher. You drop the last two 9, increase this 9 by 1, that gives you 1.0. So the three significant figures, the atomic weight of oxygen is 16.0. And I forgot to mention the important information, test number 1, the molecular weight of a compound is the sum of all atomic weights in that compound. Like I said earlier this semester, I've cut way down on memorization on my test. So we have 2 hydrogen, 1 oxygen. Each hydrogen is 1.01. Each oxygen is 6.0. Multiply 2.02, 16.0. Add them up, you get 18.02. Now, when you add, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures. So for 2.02, to the right of this decimal, you have anything after the decimal is significant, 2 significant figures. For 16.0, the 0 after the decimal is significant. So that's 1, which is lower, 2 or 1. Hopefully you pick 2 is wrong. 1 is correct. Tried to fool you. Didn't. But anyways, keep the 0. That's your first significant figure to the right of the decimal. You use the 2 to round off. That's 4 or less. Drop it. And using atomic weights, the 3 significant figures, the atomic or molecular weight, not the atomic, molecular weight of water is 18.0. And if we look at sulfuric acid, that's what H2SO4 is. What's the molecular weight? I use MW for shorthand for molecular weight of water. It's got 2 hydrogens, 1 sulfur, 4 oxygen. Now, what's the atomic weight of sulfur to 3 significant figures? Well, sulfur S is located here, and you see 32.066. Your turn. I'll let you round that off to 3 significant figures. When you're done, give me a thumbs up. I just noticed we have G squared today. All right, keep the 32. That's 3 is 1 significant, 2 is another decimal. The 0 is my third one. Use the 6 first one to round off. That's 5 or higher. Drop those 2 6s, increase the 0 to 0.1. And I got it right. Yay. And you multiply, you got 2.02, 32.1, 4 times, I forgot the bracket there, 16.0 is this. Now you add them up, and I actually put an extra decimal point. Sorry about that. But anyways, 2 past the decimal, 1, 1, round this off to 1 past the decimal, and you get 98.1. By the way, sulfuric acid, H2SO4, I still believe, it used to be a couple of years ago, is the most, widely used chemical in the world. It's used for many, many things, and it's included in the battery acid in car batteries, among other things. All right, let's look at number 15, 8 points. How many moles are 34.56 grams of water? What are we trying to find? moles of water. What are we given? A weight. Now, this is the only number I have to start with. And here, I'm trying to go to moles of water. How do we know that? Well, we figured that out at the beginning. If I had a ratio to convert this grams of water to moles of water, what would go on top of the ratio? Time to use, and I haven't done this today, so I better use this too. Time to use your good buddy, your good friend, unit analysis. I love that siren whistle. And whatever you're trying to get to, moles of water goes on top of the ratio. Whatever you're trying to get rid of, grams of water go underneath. And where do we get these numbers? Well, in case you forgot, you look at important information. Test number 1, 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams. So I need to find the molecular weight of water. Now, since we did this a little while ago, I'll just really quickly go through it. Water, the molecular weight is here, has 2 hydrogen, 1 oxygen, 2 times, and that should be a 1, not a 2, is 202. This is right, add it up. 2 past decimal, 1. And what do you have here? You have 18.0. So for every 1 mole of water, the molecular weight tells you how many grams of water there are, 18.0. And that's where I got these numbers. Once again, please use proper significant figures for all calculated answers. Here I have 4 significant figures. 1 is an exact number, and 18.0 is 3 significant. And when you do that, you get the same number of significant figures in your final answer, in this case 3, as the number that had the fewest significant figures in your multiplication division. And there's the answer. All right, let's look at number, let's do 18. KOH is potassium hydroxide. That's also a widely used chemical in the chemical industry, widely. And the question being asked is, how many grams are 56.1 moles of KOH? KOH, potassium hydroxide. So what are we trying to find? Grams of KOH. What are we given? 56.1 moles of KOH. Well, the only number I have to start with is this, moles of KOH. What units do I want my answer to be in? Grams of KOH. So I wrote it after the equal, grams of KOH. And then you use your good buddy, your good friend, unit analysis, whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Well, where do we get these numbers? Well, in case you forgot, go to important information. 1 mole of a compound, in this case KOH, equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. Now, KOH has 1 potassium, 1 oxygen, 1 hydrogen. I didn't write it in, bad Dr. White. But let's look at the periodic table. If you look at potassium, you see 39.098. I'll let you round that off to 3 significant figures, and then I'll do it. Your turn to have some fun. And when you're done rounding off the three significant figures, give me a thumbs up. All right, let's get going. How do you round 39.098 to three significant figures? Keep the first significant figure 3. Keep the second 9. 0 after a decimal point is significant. That's my third one. The next number I use to round off. The 9 is that 4 or less or 5 or higher. And hopefully I'll pick 5 or higher. I drop the 9, drop the 8, increase the 0 in front of the 9 by 1. So that'd be 0.1. So it'd be 39.1. Did I get it right? And I did. And you add these up and notice you have 1, 1, 2 past the decimal. You get the same number of significant figures in your final answer as the number with the lowest significant figures to the right of the decimal. So 0.11, round that off to one significant figure to the right of the decimal. Keep the 1, first one. The second one you use to round off is that 4 or less, yes. So I drop that, and the molecular weight of KOH, potassium hydroxide, is 56.1. Because 1 mole of a compound is equal to the molecular weight of the compound. That's where I get that ratio. And notice moles divided by moles cancel out. I like that, cancel out. And I'm left with grams of KOH, 3 significant, 3. My answer, 3 significant figures. All right, any questions about anything I've done so far this morning? Remember, in my class, in my world, there's no such thing as a dumb question. All right, well, let's do something I think will be helpful for you for test number 1. Remember, test number 1, you'll take at the test center or testing center next week at Glen Ellen campus of COD. Well, let's look at the following. Actually, it's not a hint. You'll be given this in the problem. All right. Everybody see the problem? How many grams hydrogen, that's H2, are needed to make 3.145 grams of NH3 ammonia? Does everybody see that? Thank you. All right. Let's do this stepwise. And I'll let you try first. What are you being asked to find? What are you given? Your turn. And once you figure out what are you given, what are you being asked to find, give me a thumbs up. All right, my turn. Well, you're asked how many grams of hydrogen, H2. And you're given 3.145 times 10 to the third grams NH3 ammonia. And you're also given this balanced chemical equation. When you see this where we're going from grams to grams in a balanced chemical equation, then you need 3 steps. And where do you find that? Well, you look at important information, test number 1, and says mass calculations. Step 1, convert mass, which mass means grams of A, to moles of A. In this case, that was ammonia. The A is whatever you're given in grams. Then you convert moles of what you just calculated to moles of your final answer, hydrogen. And finally, convert moles of your final answer to the actual grams of your final answer. So let's take a look at what we have to do. Step number 1, you convert mass, which is grams of A. In this case, the only thing we're given grams of is ammonia. And what answer do we want? Moles of that. In this case, moles of ammonia. And now it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. I'll write in those. And where do I find these numbers? From 1 mole of a compound equals the molecular weight of that compound, which, guess what? It's an important information. Test number 1. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So I need the atomic weight, or molecular weight of ammonia. So I have 3 hydrogen and 1 nitrogen. And if you look at the periodic table, which we've done, the 3 significant figures, the atomic weight of hydrogen is 1.01. For nitrogen, we've done this before, the 3 significant figures is 14.0. Do the multiplication. add them up. Notice the first number has 2 to the right of the decimal significant figures. The second one has 1. When you're adding, you get the same number of significant figures to the right of the decimal as the number with the lowest significant figures. So keep the 0, and that would be 1. Use this to round off. It's 4 or less. So for every 1 mole, there's 17.0 grams of ammonia. And notice grams of ammonia divided by grams of ammonia cancel out, because anything divided by itself is number 1, meaning it's gone. I'm left with moles of ammonia I'm trying to get to. And now I'll pick up my calculator, turn it on, clear it. Enter the first number. Don't forget scientific notation on this one, second key, double E. And I'll divide by 17.0. And my calculator gives me this number. Which had already rounded off the 3 significant figures. Notice this is 4 significant figures. This is 3 significant figures. This is an exact number. And therefore, 4 is the lowest, 3 is the lowest number. And this is already 3 significant figures. All right, now we need step number 2. Moles of A, in this case ammonia, to moles of B, and B is the molecule we're trying to get to, which is hydrogen. Now I'm going to rewrite the balanced chemical equation here because we're going to need it. And here we just figured out there's 1.85 times 10 to the squared moles of ammonia, which is what A was. What's B? Moles of what we're trying to get to, hydrogen. And guess what? It's time to use your good buddy, your good friend, unit analysis. Did I tell you I'm going for the Guinness Book of World Record saying that in one semester? I am, maybe. All right, whatever you're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Got to put the equal sign there. And where do we get those numbers? From the balanced chemical equation. The coefficient, the number in front, when there's no number, it's the number 1, tells you molar relationship. And this means 3 moles of hydrogen make 2 moles of ammonia. By the way, 1 mole of nitrogen, but we're not using that. And therefore, for every 3 moles of hydrogen, which I get from here, you use 2 moles of ammonia, or you make 2 moles, which I also got from the balanced chemical equation. Now, notice moles of ammonia divided by moles of ammonia cancel out, because anything divided by itself is the number 1. And pick up my calculator. Times 3 divided by 2. And my calculator gives me this number. But if we look here, this is 3 significant figures. The coefficients used anywhere here, and here are exact numbers. So the only thing I use to determine my number of significant figures in my answer is 3. 1, 2, 3. This is 5 or higher. So the correct answer, if you're rounding off at each step, which is what I do, is 2.78 times 10 squared. Now, I forgot to mention, but I'll mention it now and also tomorrow. When you're doing a multi-step calculation problem like this, there's two philosophies. One is you round off at each step. I'm going to round off at each step person, or you round off at the end. I'm not going to force you to do my way, even though I do mine. I've used that for calculations that, about $250,000 in chemicals were on the line if I messed up. I didn't. But if you want to do it either way, I'm going to calculate it both ways. Sometimes the answers are the same, sometimes they're different. And if they're different, if you do it either way, I'll be calculating when I do the answer key both ways. So there might be on some of these problems 2 different answers, and I'll have them. That way, I'm not going to force you to be a round off at each step person like I am. Let's continue with our problem. So we now know we need 2.78 moles of hydrogen. And now we go to step number 3. I forgot to underline step number 2. Now I did. And what do? You go to important information again. And this third step, moles of B, in this case hydrogen, to mass of B. So I want to go from moles B to mass, which B, which is grams. And here we just calculated this. We want to go to grams of this, because if you go way back here, this is what we knew our answer has to be. We figured that out. It's grams of hydrogen. And that's what my answer is. So it's time to use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top of that ratio. Whatever we're trying to get rid of goes underneath. I'll write that in. And where do we get that? And I'm going a couple minutes into when we normally would break, but I do want to finish this. We'll be finished in a couple minutes and we'll take our break then. Where do I get a relationship between moles of a compound and grams of a compound? Well, in case you forgot, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights. So I need the molecular weight of, because 1 mole equals the molecular weight of a compound. In this case, that's hydrogen, and the molecular weight of hydrogen, remember that's H2, is 2 hydrogens. We've already done this a couple times. The atomic weight of hydrogen, the 3 significant figures, is 1.01. By the way, this 2 is an exact number, so that would be 2.02, and that's the molecular weight we use. And now, before I pick up my calculator, I notice moles of hydrogen divided by moles of hydrogen. Anything divided by itself equals number 1, and it's canceled out, so I can go like this. Don't just automatically cancel things out. Check that one thing is divided by these other are the same units. I see students make that mistake all the time. And now I can happily pick up my calculator, clear it, put 2.78, second key, double E, 2 times 2.02. And my calculator gives me an answer of and remember, it said, please use proper significant figures for all calculated answers. This is 3 significant figures. This is 3 significant figures. The 1 is an exact number. Therefore, I'm going to let you round this off to 3 significant figures. Your turn. Give me a thumbs up when you're done. All right, my turn. Keep the 5, keep the 6, keep the 1. That's my 3 significant figures. Use the 5 to round off. Is that 5 or higher? Yes. So I drop that, increase this by 1. You still keep this along. So it'd be 5.62 times 10 to the second grams of hydrogen. And that's how you do it. Let's take a 5-minute break, come back at 10 o'clock, and we'll continue on. I'll see you in 5 minutes. I can get up and stretch. I'm back. Let's get going. All right, let's go through that problem I just went through again because it's an important one. And you should know how to do it. Big hint. A real big hint. Don't you like it when I'm subtle? All right, let's go through this again. Or everybody, can you see 10 points on your screen? Can you see the problem on your screen? Oh, no, you should. Thank you, Gianna. Both of you. Oh, I'm seeing double. All right. You're being asked how many grams of a molecule, in this case, hydrogen, H2, are needed to make 3.145 times 10 to the third grams of ammonia molecule. You're also given the balanced chemical equation. And from the problem, you figure out you're trying to find grams of hydrogen. You're given grams of ammonia. So, again, whenever you see a balanced chemical equation, you're going from grams of one thing to grams of another, you need 3 steps. And remember, mass means grams. And those 3 steps are convert mass of A to moles of A. Remember, mass is grams. Second step, whatever you just convert into moles A, you convert to moles of B. And finally, third step, moles of B, you now convert to mass. Remember, grams of B. And let's go through that again. First step, mass of A, in this case, that's ammonia, because that's the grams you're given, to moles of A, which is ammonia. Here's what we have. Here's what we're trying to get to. Use your good buddy, your good friend, unit analysis. Moles of ammonia go on top, grams of ammonia go underneath. Remember, 1 mole of a compound equals the molecular weight. The molecular weight is the sum of all atomic weights. And you round that off properly when you do addition. So for every 1 mole of ammonia, there's 17.0 grams of ammonia. Notice grams of ammonia divided by grams of ammonia cancel out. We're left with the right units, and that should be 3 significant figures. Now that we have moles of A, in this case ammonia, we go to step 2. Step 2 is moles of A, ammonia, to moles of B. What's B? What we're trying to get to, the molecule hydrogen. So I have moles of ammonia that I just calculated. I'm trying to get the moles of hydrogen. Use unit analysis again. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. These are the most important things I know in chemistry, and especially this concept. Where do you get the numbers? Relationship of moles of one compound to moles of another? From the balanced chemical equation. The coefficient, the number in front, tells you how many moles of each chemical that is being reacted or made. And here, the 3 in front of the hydrogen tells me 3 moles of hydrogen react when there's no number. It's the number 1. I like that. Special effects. Anyways, 1 mole of nitrogen makes 2 moles of ammonia. Why 2? Because that's the coefficient in front of NH3. So where do we get these numbers? For every 3 moles of hydrogen from the period of balanced chemical equation, we make 2 moles of ammonia. Notice moles of ammonia divided by moles of ammonia cancel out. We're left with moles of hydrogen. The coefficients from a balanced chemical equation are exact numbers. This is three significant figures, exact numbers. You round this off to three significant figures. Are we done? No, because we're trying to get 2 grams of hydrogen. Remember, you need 3 steps, not 2. So it's now step 3, moles of B, in this case, hydrogen, to mass of B. Remember, mass is grams. And we have the moles of hydrogen. We want to get the grams of hydrogen. And how do we do that? Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And that would be grams of hydrogen on top, moles of hydrogen underneath. And remember, we check, well, first of all, where do we get these numbers? Where do we get a relationship between moles of a compound and grams of a compound? From the important information test number 1, which you can go look in the lecture section of Blackboard. And 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. So I need the molecular weight of hydrogen gas, H2. The molecular weight is the sum of all atomic weights. Notice there are 2 hydrogens in hydrogen gas, H2. So 2 times H. The atomic weight for hydrogen is 1.01, the 3 significant figures, and you get 2.02. Do the math, round it off the 3 significant figures, and that's the answer. Boy, that was a lot of work, but that's why it's 10 points. Now, one thing I didn't mention, and I'll mention again either tomorrow or Wednesday, is next week, you'll be taking the test at the Glen Ellen Testing Center. And even though I've been in the testing center to pick up tests myself personally, I've never taken a test there. So I don't know how bad the distractions are, people coming and going and all that. Normally, when I give this test, any of my tests, you get 50, 55 minutes, because usually there's a class, if we're face-to-face, coming in right after mine. So I've got to get out of the room a lot of the times. However, at the testing center, you don't. So I'm going to give you a special gift. I'm going to give you, instead of 55 minutes, 75 minutes, an extra 20 minutes in case you're distracted. But my test, if you've done the practice problems, and if you've done the practice problems, you should be done in about 40. This one's a little harder, maybe 40, 45 minutes. So you should have plenty of time to finish. And with that extra time, you should have plenty of time to finish. So that's that. Any questions? I'm looking at the chat down there. And as I always try and do, which I've done, we finished up the material for test 1. So you have this week to study. And the best way to study, do the practice problems. Also look at important information, test number 1 in the lecture section of Blackboard. So you see what you should know how to use, and also what you don't have to memorize. There's still some things you'll have to memorize. All right, any more questions? Well, in that case, let me close some things. I'm looking at my list of things to do. which I already knew, but I just want to double check. And guess what time it is? No, it's not. I had a class whenever I'd say that, everybody closed their notebook and start getting ready to leave. No, it's not time to leave yet. That was a strange, they were a good class, but strange. So every time I'd say, guess what time it is? They thought, oh, he's letting us out early. But anyways, guess what time it is? It's new chapter time. And this new chapter is chapter 11. It will not be on test number 1, but it will be on coming up in the near future. Quiz number, I got to think about it, 3. And we'll have that quiz down in the future. All right. What's chapter 11? Well, let's find out. Chapter 11 deals with gases. Can everybody see that on their screen? The gases? Thank you. All right. Now, if you think about it, what's a gas? Well, it's something that has a definite shape and a definite volume. And not to scare you, but I will, blow on your hand. Go ahead, do that now. Do you feel that? That's gases of molecules hitting your hand. The next time you're outside and feeling the wind, yesterday afternoon when I was washing my car, it was a beautiful wind out, made it feel so nice. It was not too cold yet, which is why I want to wash it. And probably this afternoon, it's in my garage. I'll wax it so it'll be protected for the winter. But anyways, when I was feeling the wind on me, didn't knock me over, but I was probably the only one on my block thinking, wow, that's molecules of chemicals hitting me. They're gases. And gases play an important role in our life. Well, if you're breathing, yeah, you know it's important. What's going in your nose or your mouth when you're into your lungs? And then when you exhale, a gas. So gases are very important. What you don't see is all around me and you too is air. And air is a gas. Now there's other types of gases, such as the gas you use to cook with, which is natural gas methane. And also, if you use a barbecue in the bottle as a liquid, but when it comes out into the burner of your barbecue, if you have a gas barbecue, it becomes a gas and is combusted, burnt, and makes heat. So gases play an important role in our life. Now, what do we mean when we talk about a gas? What are some of the behavior of gases? And by the way, switches click off. This won't be on a test, but it's still good to review. Gases consist of particles, molecules, or elements, mainly molecules. Trying to think, well, you can't have certain elements in the gas state, but not in our air. And, excuse me, they're relatively far apart. There might be a molecule here and one way over here, where in solids and liquids, they're much closer, which is why density of gases is very low. Now, these particles are moving around very quickly, zinging around. And how quickly? Well, go out and feel the wind. That's how quickly. And gas molecules, when they're around, or particles, really don't interact with each other because they're so far apart. Unless they collide, then they interact. And gases expand to fill their container. if someone were to walk in my office right now, you can see the door right there, and if they opened up a bottle of scent of roses, the gas from roses that you smell, the flowers, or if they walked in with some flowers that were giving off gas, in a little while, I would smell it. Now, if you're outside and not far away, a skunk lets loose, you smell it because the defensive weapon of a skunk, part of it becomes a gas, the odor. Oh, skunk. But anyways, luckily I've never been skunked or my sister's dogs, but more than once I've driven down the road. Oh, skunk let loose. I want to get out of here. Well, anyways, so those are properties of gases. Now, when we talk about, and the switch will be off on this slide too, but it's good knowledge for you to have, because you may use it other times in your life, is called the kinetic theory, molecular theory of gases. And this helps us understand gases. Oh, I forgot to mention, where else does gas play an important role? Well, one important part are your car tires. Your car tires are filled with gas. Now, for many, many years, they just used air, and I still use air. But a number of years ago, someone got smart, and the car companies, tire companies said, why don't we put nitrogen in there and it'll make it's better for your tires? I can debate that as a chemist, but they can also charge you more. And if you think about it, air is 80% nitrogen. So your car tires depend on gas. Now, in the engine of your car, the cylinders that go up and down that by combustion, when you burn gasoline in your car engine, if you have a gasoline engine, it moves the cylinders by forming a gas. So your cylinders of your car moving up and down because the chemical reaction going in there, that's also a gas. Boy, gases play an important part in a lot of things in our life. Oh, I just breathed again. It does. Oh, that was a bad joke. All right, let's talk about the kinetic theory of gases, which helps understand some of the physical properties of gases. Now, gas consists of small particles, atoms, or molecules that move randomly, just zinging all around with rapid velocity. Velocity is both speed and direction. I don't know if any of you have had it, but it's called a vector. And collections of these particles are in constant motion. Now, when we talk about gases, I mentioned this earlier, the attractive forces between gases can be neglected. Why? Because they're so far apart, they don't interact that way unless they collide. Now, the actual volume occupied by the gas molecules is extremely small compared to the gas volume of the gas that it occupies. What does that mean? Well, let's think about that. If you look at my room right here, it's got nitrogen, oxygen molecules. Hopefully it does. Well, it does. I'm alive. Am I? Yes, I am. All right. That's a philosophy question. This is chemistry, so we won't get into that. It's Bad Humor Monday. But each of the molecules that fill up my whole office, which is a pretty large volume, are far apart. And if you just took the molecules and pushed them all together, the actual volume that occupies just the molecules would be tiny compared to the space volume of my office. Why? Because the molecules are spread far apart. Now, the average kinetic energy of a gas, kinetic energy is motion mainly, is proportional to the Kelvin temperature. And in gases, we don't use, we measure Fahrenheit or Celsius, but then we have to convert it to Kelvin, which we'll be doing in some of the problems this chapter. Remember, this is chapter 11. They'll be on quiz number 3, not test number 1. And the speed, which is a way of describing kinetic energy of the particles, increases with temperature. So when you heat a gas up, the molecules start moving real fast. And finally, gas particles are always moving in a straight direction unless they collide. All right, again, I'm not going to ask any questions about kinetic molecular theory of gases, but it's good to understand this, to understand gases. Now, when we talk about a gas, and I'll never ask the things on this slide, what are the key properties of gas, but what can you measure? Well, you can measure pressure. What's that? We'll get to that in a little while. You can measure volume. You can measure temperature if you have a thermometer, and amount. Now, amount is weight, and the weight, as you've learned, you can convert to moles, which you will be doing. So, key properties of gases are pressure, volume, temperature, and the amount, which you can always convert to moles. What's pressure? Now, for this slide, click switches off. Pressure is the force applied per unit area. And that's the total force on a surface divided by the area of that surface. And pressure is equal force divided by area. Nobody ever uses this equation to calculate pressure. You use a gauge. Now, what's the most important pressure in our life? The atmospheric pressure. From the time you were born, the atmosphere has been pushing on us. Oh, it's pushing on us. Oh, are you ready for a bad joke my sister used to love, my younger sister? Bus driver, open the door. Never mind. It was a pretty bad joke, but it's clean. But anyways, all throughout our life, the air around us has been pushing on us. That's called the air pressure or atmospheric pressure. But because we're used to it, we don't really feel it, except sometimes when the weather changes really bad and the atmospheric pressure changes a lot, you may feel, oh, something's different, but you don't realize it's the force being pushed on your skin by the molecules of the gas around us, the atmosphere. And the measure of that pressure, atmospheric pressure, is done with a barometer. It's a device to measure the atmospheric pressure. All right, sorry for getting around. Does everybody see barometer from Wikipedia on your screen now? Thank you. All right. Now, the first person who was credited for inventing the barometer is Italian scientist Torricelli. That's the first time I've seen his first name. But anyways, I guess they called it back then physicist, but he was really a scientist. Well, physicist is science. And we'll learn later on one of the units of pressure, measuring gas pressure, is named in honor of him, called the torr, Torr, shortened name Torricelli. All right, can everybody see the little diagram on the left, right of your screen that shows a dish right here? Let's see if I can get a larger one. There you go. All right, what Torricelli did to measure the pressure of the atmosphere, the air on, remember, pressure is force per unit area. He created where he took mercury in a dish, he put in a evacuated tube, notice they say vacuum, and he measured the distance from the level of the mercury in the dish to the top of the tube. And it's a measurement, a distance. And there are various ways of measuring the distance. One is in inches, as you see here. Another is in millimeters, which is the metric way, which what we use in chemistry. So how far that pushes, or the atmospheric pressure, the gas pushing down the mercury in that dish, pushes it up the tube, and how high it pushes it up from the level in here to here is the pressure. Now, there are other ways we now have electronic means of doing it, but this was the original way. Why have in the last 20 years more we've left and don't use this? Actually, until about 10 years ago, both at COD and Elgin Community College, where I teach, let me see if I can. Not like this, but we had mercury barometers in the lab. And why don't we want to do that? Well, mercury is a very, very dangerous compound. Why so? And also, there used to be mercury thermometers when I was a kid, even through college. My college, that's a long time ago still. You go into a doctor's office and they'd have a mercury thermometer. Put it on your tongue, wait 3 minutes, come back, nurse would look at it. Now it's all digital. But mercury is very toxic. Mercury is a toxic poison. And the bad thing about mercury is cumulative. And mercury, if it get enough in your body, will do serious harm. Let's see one thing. If you notice, can mercury poisoning be? There's no cure for mercury poisoning, and either by the vapor or in food. Now, because of pollution from mercury, tuna contains some mercury. So be careful, don't eat too much, but the shrimp pie, shrimp is low. I like shrimp, and salmon is. So don't eat too much tuna. Now, there was a case in Japan, it's in Minamata disease, where the people there, because of some release from an industrial company, a chemical factory, caused them to have mercury poisoning. And I'll let you on your own look this up, mercury poisoning Japan, the Minamata, the horrific symptoms that these people suffered was criminal. And that's why we don't use mercury barometers. But nowadays, I don't know, can you see on your screen the different dials? And those are the type of barometers. And I also, in my house, I have one like this without the pretty weights in there, temperature, 3 dials, one temperature, pressure, and humidity, the one I have here, like this one, not this company. And it's good to, and I also have 2 other weather stations that I got long ago that have the barometer in there. Now, the barometric pressure, there are different units. Everybody, can you see atmospheric pressure slide on your screen? Thank you. All right. Now, 1 unit is millimeters of mercury. Remember, you measured the height of the mercury originally. And 1 millimeter mercury in honor of Torricelli is equal to 1 torr. And you should know that. But I will give that an important information, quiz number 3. I've cut down memorization. So 1 millimeter of mercury, Hg is chemical symbol for mercury, is 1 torr in honor of the Italian scientist Torricelli. Or I hope I'm pronouncing it right. I'm not Italian, nothing wrong with that. But I've never been to Italy. I've been to other parts of Europe. That's one of the things maybe I'll get one of these decades. All right, now, what's important is the pressure, atmospheric pressure at sea level, which Chicagoland is just about there. By definition, when there's no storms flowing through, the atmospheric pressure at sea level, by definition, is 760 millimeters of mercury. And this is an exact number because it's defined. And because 1 torr equals 1 millimeters of mercury at sea level in torr, the pressure is also 760. Now, an important unit that we use, and this will be an important information test or quiz number 3, is that by definition, 760 millimeters of mercury equal another unit called the atmosphere. See, I already have it written, know this, but I'll do it again. So 1 millimeter mercury equal 1 torr. Therefore, sea level, 760 millimeters of mercury equals 760 torr. And don't forget, 760 millimeters of mercury equals a new measure of pressure, the atmosphere, abbreviated ATM. And this also means since 760 millimeters of mercury equal 760 torr, this also equals 1 atmosphere. And these are the units chemists use when measuring and working with gases for pressure. Now, there are other units of pressure. One is inches of mercury, and the switch is off. Click for this slide. Now, notice 29.9 inches of mercury equals 1 atmosphere. Let's just do something. Everybody see, let me get this out of the way. Weather Underground on your screen right now. That's my favorite go-to weather website. All right, do you see that where it says Schaumburg? I could change this to Glen Ellen. And they have the temperature if you move down. And you'll see pressure, 30.18 inches. And that's really inches of mercury. They don't put that down. And that tells you the barometric pressure is a little higher than sea level, or what it should be normally, which tells you we've got fair skies out. And I'm not a weatherman, but I guess when a storm's coming through, the pressure drops very low. That's what they mean, like on this weather map, see the circle with the L in it? And that means a low pressure. And sometimes you'll see an H for high pressure. And that's relative to at sea level, 1 atmosphere equals 29.9 inches of mercury. Now, another measure of pressure, again, switches off, is called pounds per square inch. And this is also usually abbreviated PSI. By definition, 14.7 PSI equals 1 atmosphere. Now, where do we use PSI? Well, one place is your tires. Have you ever measured your tire pressure? I still use a gauge. I don't have it in here, it's in my car. But newer cars, which I don't have, you have a sensor in each tire and it can measure the pressure. And that pressure is always in PSI, pounds per square inch. And at 1 atmosphere, that's 14.7. Now, my car tires, I keep at 35 PSI. And if you go to a gas station, used to be free, most of them are, you find a compressor, and I'll teach you how a compressor works later this chapter, that tells you how to, or doesn't tell you, it pushes air into your tire, and that keeps it inflated. And we'll talk more about that this chapter too. And when I've worked in the chemical industry, I've done certain reactions or supervised it. I did in the lab and supervised it where we're at 600 PSI, which is very high pressure. And there it was an atmosphere, it was in the reactor, and we had, in cases I've worked in, it's a mixture of hydrogen gas and ammonia gas. And you're at really high pressures, which you have to be careful, can be very dangerous. So next time you see the weather report and they say the barometric pressure is, they're talking about the pressure of the air in this atmosphere around us. You know something? Let's hold off on this till either Wednesday, because this would probably be a good time, take a break. But before we do that, let me say a few things. One, test number one, which used to be my old test number two, when we were just giving tests, is probably the don't get scared, take a deep breath, let it out. Probably historically the lowest average of my tests when I used to give tests. It's the hardest of the semester. But it doesn't have to be. And I've had classes where it's not. It's been some of the highest, but most of them it's not. Why? Because there's a lot of math now. All the mole conversions, plus there's the Lewis structures, and also the electron configuration, how to do that. Now, I've gone through all that, and some of it I'll go through tomorrow, plus balanced chemical equations. I highly recommend you got all week to practice. Practice. Don't wait until right before you take the test. So take the test next week, but do the practice problems this week. Good news is you can see me on YouTube. You guys are making me a YouTube star. And you can always go back and look at problems I did. Just a quick thing before I let you go. All right, everybody see on the screen, Dr. White, my YouTube channel. And if you look there, if you open one up, and first of all, let me do this. Let me stop. If you go where it says the title, date, and show more, click on that. And that tells you everything I'm doing in that YouTube video. Again, click on the video, go underneath where you see Zoom meeting, title, date, and click on show more, and you'll see all the topics I covered. And with that, actually, I'm done for today. Again, don't forget, new login. Sorry about the confusion. Zoom did something to me. I don't know why, but it happened. It's happened once before. But anyways, with that, I'm going to say, don't forget, new office hours are now Tuesday and Wednesday from 6 to 7:15. And with that, I'll say, gang gesund. Bye now.